Good morning everyone. I am Shivani Yadav today here to discuss about preparation of alcohols from alkene. So we are going to discuss about three mechanisms. The first mechanism with concentrated H2SO4 and the second one is hydroboration oxidation and the third one is oxymercuration demercuration. In the three type of mechanism we are going to discuss about two types of law. First is Marconi-Kof's rule and the second one is anti-Marconi-Kof's rule. So let us discuss the mechanism one by one. First is hydration of alkenes with concentrated H2SO4. एल्कीन हमें पता है कि ये क्या नेचर है इसका, इलेक्ट्रॉन रिच, एंड वी आर गोइंग टू ऐड H2SO4 with water and form alcohol. It may be one propanol or it can be two propanol. So we will form the product with help of Marconi-Kof's rule. Marconi suggests that hydroxyl group attach on the carbon which contain less number of hydrogen. So in the hydration of alkene with H2SO4, it follows Marconi-Kof's rule. So this will be our main product and it is anti-Marconi-Kof's rule, as the hydroxyl group attach on the carbon which contain more number of hydrogen. Step 1. H2SO4 is a strong acid. It breaks down into H++ SO4 2-. Water is also present. It contains lone pair. It is act as nucleophile. What are nucleophile? These are the species which have containing electron rich species or having negative charge. So it is contain lone pair, so it is a nucleophilic species. The lone pair of oxygen attacks on H+. Always focus on the arrow in which the reaction is proceeding. So hydronium ion is formed. Now it becomes electron deficient. Here alkene comes to attack on hydronium ion and abstract proton from it. We number the alkene. We know that it is the main chain and alkene is our at priority. So it is first, second and third. Now there is possibility that the double bond attack, there is a possibility that carbocation forms from the first carbon or maybe from the second carbon. So how we decide? We decide by the stability of carbocation. We know it is 3 degree, 2 degree, 1 degree. So which is more stable? It is more stable. Now we proceed to step 2. In step 2, nucleophilic attack takes place. By water. Electron deficient center. So this is electron rich. The lone pair of oxygen attack on the carbocation and protonated alcohol is formed. This species is known as protonated alcohol. In step 3, deprotonation takes place. In the first step, we have taken proton from the H2SO4. Now we give back this proton to H2SO4 and H2SO4 is recovered again. CH2. Water will attack and abstract the hydrogen and alcohol is formed. And this is our Marconi-Coff product, as a hydroxyl group is attached to the carbon which contain less number of hydrogen. Now we will proceed to second mechanism. It is hydroporation and oxidation. It takes place with the help of BH3. BH3 is a Lewis acid. Boron belongs to group 13. Its size is very small and it exists as dimer in the form of B2H6. B. This bond is known as banana bond and it is 3 center 2 electron. When we add it on alkene, it acts as electrophile, and electrophile are electron deficient species. Now this alkene attacks on boron and forms a complex. So what happened here, that alkene is nucleophilic, electronphilic in nature, so it follows anti-Marconi-Coff's rule, and BH3 adds on the carbon which contain more number of hydrogen. Now it will form a 4-center transition state. Hydrogen. But BH2 still contains 2 hydrogen, and we know that it is electrophilic in nature. So now again alkene comes to attack on this hydrogen, and all the hydrogen of boron is removed and a complex of boron is formed. The structure will be trigonal planar. Now we add on peroxide, H2O2 OH minus. This will attack further and boron is removed out. And boric acid is formed. It follows anti-Marconi-Coff. Here, in this mechanism, no carbocation is formed. As we look here, it is simply go via cyclic transition state. There is no formation of intermediate as in the before mechanism. Now we discuss third mechanism, oxymercuration, demercuration. Oxymercuration and demercuration suggest that first addition addition of mercury and removal of mercury. This is the complex used here. Still here, alkene is electrophilic in nature. It attacks on mercury. Now still the question arises whether it will form Markovnikovs or anti-Markovnikovs. So it will follow Markovnikovs, but it doesn't completely follow the Markovnikovs rule. How? That no carbocation formation takes place. If no carbocation, so no rearrangement, then why we are calling it Markovnikovs? Because it is following that hydroxyl group will attach here where the carbon contains less number of hydrogen in the double bond. Still we number is 1, 2, 3 as it is main chain. Now the double bond attacks on mercury and remove this group out. So a complex formed Hg OAC O2 AgOAC. Here a 3-member cyclic transition state is formed and it will contain positive and negative charge. Due to this complex formation, a partial positive charge forms on the second carbon and the negative charge forms on the third carbon. So the nucleophile attacks on the second carbon and a protonated alcohol forms with the mercury complex. Till this process we call it oxymercuration, means addition of mercury take place. Now we require demercuration. For the demercuration we need removal of HgOAC group from this group and we add NaBH4 in basic medium. Now the H- go attack here and remove out this group. And further deprotonation takes place and desired alcohol is formed. Now we summarize the 3 mechanisms with the help of concentrated H2SO4, hydroboration oxidation, and the third one is oxymercuration demercuration. In this, Markovnikov's rule is formed, anti-Markovnikov's rule is followed, and in oxymercuration demercuration, Markovnikov's rule is formed, but formation of carbocation doesn't take place. These 3 methods are used to prepare different type of alcohols. It can be 1 degree, 2 degree and 3 degree. But these all 3 mechanisms cannot be used for the formation of phenols. That's all. Thank you.